In this video tutorial, I am going to explain how to draw the helical gear with Involute tooth profile using SolidWorks. So consider the number of teeth as 30, module is some 5, helix angle some 15. From these three input parameters, the transverse module is circle diameter, addendum circle diameter, dedendum circle dia, tooth thickness, fillet radius, etc. can be calculated by using the Excel sheet as shown here. This is the Involute equation. So using this equation, Involute profile can be obtained in SolidWorks. Here R is the radius of the dedendum circle. This circle diameter is 142.79. 142.79. Take one more circle. This is representing the pitch circle. So pitch circle diameter is 155.29. So here this value is 155.29 by 2. That is the radius. So this is also a construction circle. Okay. Now take one more circle. This is for addendum circle. This dimension is addendum circle dia is 165.29. So this value is 165.29 by 2. So this is also a construction circle. Okay. So this dimension is also not required to us. These are the three circles: addendum, pitch circle, and dedendum circle. Now take some center line. This is for construction purpose. So draw this line up to the dedendum circle, something like this. So from this point onwards, I want to draw the Involute profile. So go to this spline command and equation driven curve. Select this and select a parametric equation. XT YT equations are available here. Now this is the XT equation, that is XT equal to R into cos t plus t sin t. So copy this and paste this here. This R value is 71.39. This is the R value, 71.39. So here in place of R, 71.39. Next, YT equation is this. This is the YT equation. Copy this and paste that here. So R value is again 71.39. T1 value, that is the starting value of this T, that you take as 0. T2 value assume as some 10. Now observe. So this is the Involute profile created. So this is the complete profile. This complete profile is not required. You take up to some 5. So up to 5 is also not required. You take up to 1. So up to 1 is sufficient. So take T value from 0 to 1 and click on OK. Now Involute profile is created. So this complete Involute profile is not required. Up to the addendum circle is sufficient. So go to trim command and trim this portion. So this portion of the Involute profile is sufficient for us. So now observe here, tooth thickness is 7.854. So tooth thickness will measure along the pitch circle. You take a center line, construction line, from this center to this intersection point. Okay. Now from here onwards, you have to measure the tooth thickness, that is 7.854. So now take again line, again one more construction line, draw up to somewhere here randomly, then go to dimensions, here to here descend. This arc length is required for us. This arc length is 7.854. So take this as 7.854. So this is the tooth thickness. So now half of that is to get the mirror image of this particular involute profile. I am drawing one more line from this center to somewhere here, but this distance is this arc length is 7.85 by 2. 7.85 by 2. So 3.9. This is the arc length. Okay. Now take mirror image, go to the mirror entities, select the involute profile and mirror about this line. Now you got the mirror image of this one. And take the mirror image of this line about this line. Something like this. Okay. Now, so about this line, you take the mirror image of this entire profile. Now again go to mirror, select this and this involute profile, mirror about this line. Okay. Now you got the mirror image of this. If you observe, all these lines are not required to us. We require only this portion of the involute profile, remaining all are not required. So one by one delete all the lines. This line, this line, this line, all the lines. Now we can delete. We can delete this portion also. Full circles. You can treat them as full circles. This circle is not required. Now go to the trim command, trim this portion. So this portion only is required to us. Now exit, zoom out, then go to the front plane, take new sketch, take circle command, from the center to up to here, you draw one circle. Now exit from the sketcher, see this in the isometric view, go to features, extrude this, change the direction, extrude direction like this, such that you can see the profile. Extrude distance is the face width, that is 75. Click on OK. After extruding this, so select this particular face, create a new sketch, see this from the front, draw a circle, like this, exit from the sketcher, go to the isometric view, then go to file, insert, curve, helix. So this helix you have to start from this point. So here you take the options as a height and pitch, and height is here 75 only. Okay, choose this as reverse direction. Angle is 0 means it is somewhere here. 0 means somewhere here. Now zoom this area and just slowly increase the angle. This is 5. 5 means 5 means 6 means somewhere here. 5 means somewhere here. You take 5.5. Okay, 5.5 is sufficient. Now go to this side view and observe the helix. So it is pitch value is not properly there. So increase the pitch value such that you can get the required helix angle. So this will take around some 2500. Okay, 2500, something like this. So now to measure the helix angle, go to evaluate, measure, select this point to point distance, this point to this point distance you select. Delta Z is 75, This opposite side length delta y is 15.56. So this angle is the helix angle. Now helix angle is delta y, that is 15.56 by 75. So use Excel sheet here. This is 15.56 and this is 75. So helix angle is 11.72. So to get some 15 helix angle, you have to adjust this. Now again go to helix, edit, helix, edit. Now adjust this 15. So 11, 15 means it has to move in this direction. 2350 I will take. 2350. Now again measure the. Okay. Now see this from the side. So this is 16.54. Now enter this as 16.54. 16.54. Now it is 12. So something like this you have to adjust these values until you will get the desired helix angle. So this dy value you have to increase. So such that you can get some 15 degrees. Now I will do this for 12.5 degrees. 12.44. Assume that is 12.5. 12.5 degrees. Next. Now go to the features. Here take the sweep cut option. Take the sweep cut option. This is the profile. So here you have to select the profile. So this profile you select. This profile. Okay. So this is the path. This helical curve you select as path. Okay. Click on OK. Now, so space for one particular teeth is generated. Now go to the linear pattern. In linear pattern, take circular pattern option. Then select the feature as this sweep cut feature. And here you select this circle to get the center of the circle. So in 360 degrees. So number of teeth required is 30. So that's why I am entering 30. Click on OK. So now helical teeth with involute profile. Helical teeth with involute profile is generated. Here on this particular face, right click and create a new sketch. See this from the front. So here draw a circle at the center, draw a circle of some dia 30. Then draw a rectangle here. With some 7.5 side, that is d by 4 or 30 by 4 in this area to get the keyway. Next, see this from the isometric view and go to features, then take extruded cut, and extruded cut option you can take up to this surface. Okay. Then helical gear with